This is the second part of the second subunit of the first unit of grade 9 physics, the addition and subtraction of vectors. If you have not seen the first part, I really recommend you see the first part before you see this part. Now, we saw in the first part of the addition and subtraction of vectors how to add and subtract parallel or perpendicular vectors. That brings the question, what if they're neither parallel or perpendicular? Well, you use a method known as the resolving method, okay, or you resolve the vectors. What does this mean? Resolve, well, kind of means finding the solution, which is what you do. So in order to resolve vectors, you use a combination of parallel and perpendicular vector method of adding and subtracting vectors. That's why you need to see the previous video before you understand this one. All right, so step one is to find the components of each vector, which means splitting it into the x and y parts. Alright, so what that means is, let's say we have two vectors. We have vector A and we have vector B. Now, you can see that these two vectors, they're not parallel and they're not perpendicular. So we have to use the resolving method in order to find the solution of these two vectors. So let's start with A. We have to divide these vectors into two components. Any vector can always be split, in a sense, into what you call the components of the vectors. Usually we use x and y components. What you do is, from the tail point of vector A, draw a horizontal line. From the same tail point of vector A, draw a vertical line, right? So you have a horizontal and have a vertical line. Now from the head of vector A, draw a vertical line, or a vertical dotted line, and a horizontal dotted line. Okay, so this is all going to make sense in a bit. Now, from the tail of vector A, let me use a different color so we can see this clearly. From the tail of vector A until the dotted vertical line, we form a vector known as AX, or the x component of A. Again, from the tail of vector A, we form a vertical line until the dotted line, and we call this the y component of A. There is a mathematical solution to find the actual value of AX and AY, but we first have to understand the graphical representation. So you see that I have split A into two vectors, AY and AX, okay? How can I do this? Well, if you add AY and AX, you come right back to A, right? So resolving a vector, or splitting a vector into its components, is basically the opposite of adding a perpendicular vector. So let's do the same thing with vector B. All right, if I were to draw it, it would be a value like this for Bx and something like this for By. So you can see again, if I were to add Bx and By, I would get right back to B. And if I were to split B, I would get Bx and By. So now we have the two components of each of the vectors. So step 2 says we have to combine similar components using the parallel vector method of addition and subtraction of vectors. Now, let's draw again the components that we found. We found vector AYs and AX, AY and AX, and we found vector BY and BX. Correct? Now, what do you see here? We see that AY and BY are actually parallel to each other, and AX and BX are also parallel to each other. So we combine the two. So we can change this to being AY plus BY and AX plus BX. These two are parallel vectors. AY and BY are parallel, and AX and BX are parallel. So we can simply add it. So let's say the combination of AY and BY is a larger vector, CY. And the combination of AX, BX is a larger vector, CX. Okay? So we know how to do this. We know how to find the solution, or find the resultant of parallel vectors, which are AY and BY and AX and BX. All right? Next, find the final answer by using perpendicular method solution of finding the vectors, of finding the resultant vectors. So you see, you have to know how to do parallel and perpendicular vectors. Well, what is the final result we found there? We found that we know a CY and we know CX. Correct? So what are we looking for? We're looking for this final answer C, our final resultant, doing all those steps just to get this final value C. And we know how to do this. We have to use the Pythagoras theorem. All right, we have to use the Pythagoras theorem. In this case, it'll be c squared is equal to cx squared plus cy squared to find the magnitude. And we have to use trigonometric values, cy over cx, in order to find the direction. So we find the direction and magnitude by doing these steps. That's it, all right? Let's go through the steps again. The first step, you find the components of the vectors. Split the vectors. Divide the vectors into an x, and a y component. Second, for the 2 vectors, or even 3 vectors, 4 vectors, any amount of vectors, add all the parallel vectors together. So add all of the y's together, add all of the x's together, right? Once you do that, you're going to find 1 vector in the y direction and 1 vector in the x direction. So we know that the x and y are definitely perpendicular. So all we have to do is find the magnitude and the direction of the final resultant vector. And that's how you resolve vectors. That is the end of the second subunit. Long unit. All right. Stay tuned for the third and final subunit of this first unit of grade 9 physics.